Hey guys, Mr. Fawcett back here with part 2 of this lesson, estimating limits from graphs and tables. In our previous lesson, we strictly talked about graphs, and today we're going to do a part 2 on looking at limits given a table. Again, I encourage you, whenever we get a problem, that you pause the video, you try it on your own before you compare your solutions, or so you can compare your solutions to mine. So we are going to go to the bottom of the second page, I believe. We're down at number 7. Let me pull up my pen. All right, and it says use the table to evaluate the following. And we're given a limit where it says the limit of f of x as x approaches 5 is equal to blank. Now, with graphs, it was usually a little bit easier to figure out the limit because we could literally put our pencil or pen or finger on the paper and just trace the function from both sides to see where it was going. So again, just a little refresher. Let's say this is x equals 5. Let's say this is my function. We'll call this 3. So again, we would get out our pencil, we trace the function from the right-hand side towards x equals 5, trace it from the left-hand side towards x equals 5, and we could see that the limit was about equal to 3. With the table, it's a little different because you can't, trace the actual function on paper. You kind of got to think about what's going on with the numbers given in the table. It's not too bad though. We can still draw some arrows here to have that visual for us, but we still need to look at both sides, both the one-sided limits. So if I look at the function approaching 5 from the right-hand side, right, that would be coming this way. Well, I can see that the numbers go from 76.5 to 75.1 to 75.01 as we get closer to 5, right? So it looks like they're approaching 75 from the right-hand side. If I look at the other side, right, as I approach 5 from the left-hand side or the negative side, the numbers start at 73.5, 74.8, 74.98 as they get close to 5. So it also looks like they're approaching 75. And right, our definition of a limit, we'll formalize that later in the lesson, but it needs to approach the same number from both sides of the function. And from this table, we can see that it does. It approaches 75. So same idea as a graph, just a different representation. Take a look at number 8. They give you a table, and they give you 3 possible choices for what the table or what limit the table is representing. All right, so look through them, look through all 3 of them. Not only try to pick out the correct answer, but also see if you could pick out why the other 2 answers are incorrect. Okay, hopefully you've had time to give it a whirl on your own. Let's first look at A. So it says the limit as x approaches 12 from the positive side of f of x is equal to 8. So essentially, we would need to see numbers that are greater than 12 in the table for our x values, right? Because you could think of a number line, right? If here's 12, if we are approaching from the positive side, that means we're coming in this way, which means we should see numbers like 13 or 12.5 or 12.1 or 12.2, etc. Okay, so in the table, all of the numbers that we see are less than 12. So this table is not showing us the function approaching from the right. It's showing us the function approaching from the left. So it actually is only showing us a one-sided limit. So right away we could eliminate A. And if it's not showing us both one-sided limits, well, we can't make an inference about the whole limit, right? So that also eliminates C because we need to see both one-sided limits for that. So our choice ends up being B, but let's also make sure that the limit is going to be equal to 8. So as we approach 12, all right, we go from 7 to 7.5 to 7.9 to 7.99, etc. And we can clearly see that this limit is approaching 8. Okay, so in the space below, you would want to touch on the fact that the table is not showing us the approach from the right-hand side. And if it's not showing us the approach from the right-hand side, we also can't make any inferences about the whole limit. We can only make an inference about the limit coming from the left hand or the negative side. All right, let's move on to the next page. All right, so sometimes a table may not be given to you, but you can create one to help evaluate the limit. We're going to use our TI-84s or whatever kind of graphing calculator you have in front of you to do that. Hopefully you've created tables before in Pre-Calc or Algebra 2. If you haven't, I am going to walk you through it using some software I have downloaded on my computer, and you should be able to follow along with your calculator at home. So we're trying to evaluate this limit right here as x approaches 0, and actually gives us the function, right? It tells us that x is being divided by the quantity square root of x plus 1 minus 1. So let me pull up my software. Okay, I've already entered this function in y1. Looks like I actually need to add an extra parentheses here. Not an extra one, but one that is required. So once you have that entered into y1, you can now, let me get rid of this black arrow as well, actually. Okay. You also want to make sure that your table is going up by the correct increment. So if we go back to the document, we see that the table starts at negative 0.003, and it's going up by 1,000th every time. So we need to replicate that on our calculator. So what you can do is do second window, because that'll go to your table set. You want to make sure your table starts at negative 0.003, and that your table increments right here are going up by 1,000th every time. Once you have that inserted or entered, you can click second graph. That will bring up your table, and it will give you the y values for each of these x values. So obviously we're really only looking at these right here, because that's what the table has on our paper. So you could go ahead and fill in those y values for each of the x values on your paper. I'm not going to do that. I'm just going to talk about it right here. We can see that as we get closer to 0 from the negative side, we seem to be approaching 2. Right? It doesn't matter that the function is not defined or does not exist at x equals 0. We just know that we are approaching 2. Same thing if we come in from the positive side. Right? If you look at these numbers right here, they are getting smaller. Right? 2.0015 is larger than 2.001, which is larger than 2.0005. And they are eventually converging to 2. So the answer to our question here would be 2. And again, you could fill in those values on your table from your calculator, but I'm not going to do that for sake of time. Let's move on. Let's look at the next problem down here. So it gives us a function. It tells us that our function is sine of 1 over x. So let's enter that in our calculator. I'm going to pause the video and enter this information, then start it up again, just again for sake of time. All right, so I've entered the function in our calculator, and you actually don't have to create any table for this. I've actually already entered the values for you right here. So we really just have to look at the values and try to figure out what's going on with this graph and this limit. Straight away, let's first look at the table before we take a look at what the graph looks like. Notice that we're looking for the function as, or the limit of the function as x approaches 0 from the positive side. So even though we're moving this way on our table, you still want to realize that the numbers are starting out from 2 over pi, which is larger than 2 over 9 pi. So we're still approaching from the right, even though our arrow is being drawn in what is the opposite direction to what we're used to. As we look at these values, right, we go from 1 to -1 to 1 to -1 to 1, and then we eventually get to, well, if we get to 0, we know that the function's undefined or does not exist. The problem is, what does it look like we are approaching? Are we approaching 1? Are we approaching -1? Or are we approaching some value in between 1 and -1? Because from the table it's not clear. It just looks like the function's bouncing back and forth. Let's take a look at the graph and see if that gives us any further insight. So let me get rid of this. I have entered our function. Okay, sine of 1 over x. One thing to be sure of is that click your mode button. Make sure your calculator's in radians and not degrees. Most of the time in calculus we'll be working with radians. And if we aren't, it'll be clear that we need to start working with degrees. But you can always assume that when we're doing trig functions, unless it says differently, stick with radians. So I've entered the function, click the graph button, and again, it's not super clear what's going on. As we approach from the left, we kind of bounce down, then go up, and then something happens, and from the right, we go up and then down, and then something else happens. So it doesn't seem too clear from this window size what's going on, but maybe if we zoom in, it'll become more clear. So I'm going to click the zoom button. I'm going to go to option 2 to zoom in, and I'm just going to click enter once. So again, the function looks like it's bouncing up and down as it approaches 0, but maybe if we click zoom one or two more times, we get another idea of what's going on. So again, here we can clearly see that the function is just bouncing back and forth from +1 to -1 as we get closer and closer to 0. And if you really zoom in, again, it just keeps doing that even more rapidly as we move towards 0. So this is what we call an oscillating function. It actually doesn't approach any certain number as we move toward 0. It just bounces back and forth between 1 and -1. So this limit right here, because it does not approach a single number and it just oscillates, the limit does not exist, regardless of what side you're coming into. We were only looking at the positive limit here, but we could also look at the negative limit or the whole limit. We just kind of talked through these questions. So what appears to be happening to the graph around x equals 0? Function bounces. And again, a better word for this is oscillates. Bounces between -1 and 1. So question 11, explain in your own words another instance of when a limit does not exist. Well, and you could just say when a function is oscillating between two numbers. I'm not going to write that down because we've kind of talked about it a couple times now. But if a function is oscillating or bouncing back and forth between two different values, it's not going to approach either of the values. It's just, you know, bouncing back and forth. All right, let's move on. Let me erase this. All right, and we are getting close to the end of this video, and then you guys will have some time to do some practice. So, common types of behavior associated with the non-existence of a limit, and this is kind of what we've just worked through. Number 1, f of x approaches a different number from the right side of c than it approaches from the left side. So this is just, you know, whether you're tracing on your graph, whether you're looking at the table, if the one-sided limits are not equal to one another, then the limit is not going to exist. And I think we've hammered that home pretty well the last couple of lessons. Number 2, f of x increases or decreases without bound as x approaches c. Maybe we're unclear of what increases or decreases without bound means. And all this means is that the function is approaching positive or negative infinity. So let's say this is -2, and let's say our function we'll make sure that it's clear that there's an asymptote here. So as the function approaches -2, the left and the right hand side are both approaching positive infinity. So again, because they're approaching a not, like infinity, remember, is an idea. So they're not approaching a real number. They're just increasing without bound. That's what it means when they say they're approaching infinity or negative infinity. So again, these limits technically don't exist unless we're talking about infinite limits. And then it would be acceptable to say, okay, the answer to this is positive infinity. And number 3, if f of x oscillates between two fixed values as x approaches c. So again, that is just what is going on here, where the function is bouncing back and forth between 1 and -1. It's not approaching any specific value. So those are the 3 times when a limit is not going to exist. And then down here, if we look at the limit existence theorem, this tells us when a limit will exist. So the limit of f of x as x approaches a exists if and only if the limit as x approaches a from the positive side of f of x is equal to the limit as x approaches a from the negative side of f of x is equal to b, where b is a real number. So to put this in, I don't know, I guess more common words, both one-sided limits must exist. They must be equal to one another, and they both must equal a real number. So they both can equal positive infinity, and we can say that they're equal to one another because infinity is not a real number, right? So the two one-sided limits must exist, they must equal a real number, and they must be equal to one another. If that is true, then the limit will exist at that x value. Okay, you guys have some practice throughout the rest of this packet, so you can get working on that, and always come prepared to class with any questions that you may have. All right, this is Mr. Fawcett. Enjoy the rest of your day.